All right, these are your second set of notes for this week, your last notes for this semester. So let's do this. This is from chapter 13, section 5, and it's page 873. Make sure you've got your name, date, period. You absolutely need your book today, so go get it. Pause if you need to. This is notes 26, probability models. The EQ, essential question, is how do I construct and use probability models? So here's our question on the left. Sorry, I'll move it around a little bit. What do I do if it says and or? So if it says and, what do you do? If it says or, what do you do? So the warm-up problem should be done in class. And just remember, once you are done with notes, do the rest of the 3 questions per page on the left and do your summary at the end. Okay, so there's a little bit of notes to copy down, and then we're just going to do examples out of the book because these involve tables, and it's better if we just use the tables that are already drawn in the book. So the first thing to copy down for these notes is a two-way frequency table. It displays the frequencies of data in 2 different categories. So it has a category on the left side and a category on the top. So in the last section, or was it 2 ago? Let me flip back and see. I think it was 13-2. In 13-2, we had frequency tables. So it might have the type of preferred music. So rock, hip hop, country. But then there's going to be another category. So one category could be preferred music, and then you could break apart those people that were asked questions by age. So you could have the type of music going down left and right, and then their age categories on the top. Or it could be male versus female on the top. Or it could be anything, any kind of category you could group people into. So preferred music and then something else to separate the people. Could be what city do they live in, if they live in Jurupa Valley or Eastvale or Riverside, just for example. Okay, so a two-way frequency table is now making the tables a little bit bigger and showing different types of data. And then this is the next part that we'll go over today. Okay, so conditional probability. It's a little bit confusing, but once we do examples, I think you guys will get it. It is probability that an event will occur given that another event has already occurred. So it's going to say what's the probability of this given that this has already happened, or given that we already know this, something like that. It's written a little bit differently. So I'm going to go ahead and trace over this so you guys can see how to write it. Remember to pause if you need to, if I start to move too fast, but we will write conditional probability as P for probability. In parentheses is the probability of what? So it's for event B. And then this vertical line means given that event A has already occurred. So probability of event B given event A. It's read as the probability of event B given event A. So I already said that. So anyways, the way you calculate it is like this. This is basically the formula. And it's kind of weird, probably the way I wrote it, but this is what I think of. And it's once you see the tables, you'll be like, oh, okay, that makes sense. So probability of event B given event A is the number from the table, the frequency number of B and A. So B will be one column or row, and then A will be another one. And then divide by the total number of A. So you're going to look for a total, not the grand total, just the total from A. So whatever comes second, that's the total that you divide by. In fact, I'm going to use a color to make that stand out a little bit more. So notice that whatever comes second, that's the one that you divide by. Okay, so finish copying this, and then we're going to move on to the book and do some examples straight out of there. If you don't have your book, you can write the examples in the notes. So it says all examples will be in the book, page 873 through 875. And the examples in the book are very similar to your Math Excel homework. Okay, so if you're not done writing this, pause, because I'm going to change it now. All right, so this is the book, chapter 13, section 5. And let me focus it because it looks a little bit blurry. So we're just going to focus down here at the bottom and do this problem. Also, you guys feel free to read through what it says in the book. That's basically what we wrote down. So you can use two-way frequency tables to organize data and identify sample spaces to approximate probabilities. So here's our first problem. And let's just look at this. This is a two-way frequency table. Here's one category. It's what do you call it? Grade level. Grade level. Going down. And then I'm going to have to move this. There. Okay, the other category is right here, which is second category, which is gender. There. Okay, so that's why it's called a two-way frequency table. In the other section, we only had one category and then the frequencies. Okay, so let's go ahead and get started. So this one says, and I already wrote on this quite a bit and I had to white out my work. So I'm sorry if it looks kind of yucky, but that's what I got. I only have the one book. So the two-way frequency table at the right shows the number of male and female students by grade level, male and female by junior and senior grade levels. On the prom committee, what is the probability that the member of the prom committee is a male who is a junior? So on these problems, when it's just straight out saying what's the probability, blah, 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 you will have to divide by the total, by the grand total. And this is the grand total. Right there. It's the total of juniors and seniors, and it's the total of males and females. Either way you look at it, it should equal 12. So that means there's 12 people on the prom committee. That's a good way of thinking about it. So anyways, probability that they are male who is a junior. A male, I'll just put male junior. So I kind of already wrote on this and I can't white out highlighter, but you can see how across I'm looking at juniors and up and down I'm looking at males, male junior, and then that's the number. There are 3 male juniors. There's also 3 male seniors. So it's 3 male juniors divided by the total, which is 12. You can reduce it and get divide by 3 to the top and bottom and you get 1/4. Is that right? Divide by 3. Yeah. And then you could also use your calculator and divide it and get the decimal, which is 0.25 or 25%. It doesn't tell you how to write your answer. I forgot what MathExcel said, but those are the 3 ways. Either reduce the fraction, write it as a decimal, or get the percentage. Okay, so we're going to move on to the next page. Okay. I might start going a little bit quicker just so that we can get this done. I don't want another 30-minute note video for you guys. I'm sorry that happens sometimes. So anyways, we're doing the same thing. These are the ones where you divide by the grand total. The total, grand total, rather than a category total. So anyways, use the frequency table to find the probability of each event. So probability of an 8th grade boy, this is attendance at a soccer camp. So for number 1, I'm not going to use a highlighter. I'll just use a pen. I'm going to look at 8th grade boy. So 8th graders, I'm just going to draw a line down to show it's here. And then boys right here. I have the total boys is 23, but what I want is 8th grader boys, it's 10. So it would be 10 out of the whole total, which is 50. We always want to reduce, so that would be 1/5. Divide the top and bottom by 10. And that would be, if you use your calculator, or you might know this one, 0.20 or 20%, or it'd just be 0.2. Okay. And then the next one, this is the probability of a 6th grade girl. So I'm going to use green for that. So 6th grade is right here going down. There's the boys, girls in total. And then girls is right here. So that shows right here. It would be 8. 6th grade and girl. It's like going down and across, and where they meet, that's the value. So it would be 8 out of the grand total, which is 50. I can divide by 2. I think just by 2. Divide the top and bottom by 2, so I get 4 over 25. And as a decimal, I just divided it real quick. It's 0.16 or 16%. So 16% of the attendants at soccer camp were 6th grade girls, and from up above, 20% were 8th grade boys. So that's how you do that. It's kind of more simple. Once we do the next one, you got to think a little bit more. So write this down, the part that I put in purple pen. So it says the probability that an event will occur. All right, so my doorbell rang. I forgot where we were at. So I'm going to just keep reading this. Okay, so, all right. So the probability that an event will occur given that another event has already occurred is called conditional probability. So we wrote that in the notes already. It's, whoa, it's really big. It's that part right there. Conditional probability. And we wrote the formula, but it's also good to write it down in the workbook since we're going to be doing examples right here about that. This one will be just like this. So you can write conditional probability of event B given that event A has already occurred as P parenthesis B, then that line A parenthesis. And you read it as the probability of event B given event A. So up above this section, so all of the problems above, you're dividing by the grand total. But below here, this is where you're going to be dividing by the total of a certain category. So like, well, I'll show you when we get to it. So anyways, write this down. That way you have that to help you. And again, I whited out stuff because I didn't like how I wrote it from before, but it's really like the number from B and A divided by the total number from A. This is when it says given event A. So again, notice how whatever comes second, if it's written this way, that's what we divide by. Whatever it says given that. Given event A, if it says given, that's the one you divide by. Okay, that's good enough. Okay, so let's go ahead and look at this example. This got it problem. Sorry, there we go. No, that's not good. This paper looks shiny. So again, I already had highlighted this from previously, but I had to white out right down here. So sorry about that. So anyways, here we have a table, a frequency table, and it says what is the probability that a randomly selected person is 30 to 45 years old, given that the person is in favor of the minimum wage bill. So like that's a law saying something about minimum wage. So we have our age groups right here, different ages, and the total number of people that are for. Sorry, I was looking. This is the grand total. And then over here, we've got people that were for the bill, against the bill. Some people have no opinion. They're like, I don't really care one way or the other. It doesn't matter. And then the totals for each age groups go across. The totals for the age groups go across, and the totals for the for are at the bottom, against and no opinion at the bottom. Here's the grand total. But we won't be dividing by it this time. But that is the grand total. So anyways, what we need to find is probability that someone is 30 to 45 years old. And then I'm going to do that line, given that they are in favor. So I'm going to put in favor means for. I wish they would have just said for. That way it makes more sense. Okay, so what I need to do is find out the probability of both of them, 30 to 45 and their 4. I already have it highlighted, it's that one. And then you divide by the total for 4. Total 4, 30 to 45 and 4. Okay, so the total, sorry, not the total, the number of people who are 30 to 45 and for the bill is 200. And then you divide by the total for the 4. So whatever comes second, that's the total you look at. 4 goes straight down. That gives you the total for 4. 780. You can leave it like that or divide it in your calculator and get a decimal. 200 divided by 780. Ooh, that's going to be approximately 0.26 or 26%. Yeah, sorry, I just realized that you couldn't see what I was writing. There it is. Okay, so just to review that, since now you can see it, we're doing the probability of someone that's 30 to 45 and they're for the bill. So on the top, it's the people who are 30 to 45 and 4 divided by the total that are for the bill. No matter what age they are, it's the total that are for. So it was 200 divided by 780. And that's our answer. That's what we get. All right, so pause it if you need to copy it. Otherwise, I'm moving on to the next one. Actually, we're skipping that one. Okay, so here's some practice problems right there. All right, so we are, all right, so we've got a similar, no, it's the same. This is the same table from the other problem on this page, the number 1 and 2 for the practice, but now it's asking us different questions where we are finding conditional probability. So the first one is probability that it's a 6th grade boy, or sorry, that it's a 6th grader, given that we already know it's a boy. So we will find the number from the table where there's 6th grade and a boy, and then divide by the total number of boys. And you can see I already highlighted, this one is the yellow. So boys go straight across, and then we're finding 6th grade right down. So 7 is our top number. I like to highlight it because then it really makes it obvious it's right here and then right here. That is our number of 6th graders and boys. 6th grader boy. And then divide by the total number of boys. So you go to boys straight across and it's 23. So 7 over 23. And then I can divide to get the decimal. Oh my gosh, where's my calculator? Okay. 7 divided by 23 is about 0.30 or 30%. All right, let me move it up. Okay, so now we can see the bottom question